Now let us see a special progression called as arithmetico-geometric progression, also known as AGP. It is a sequence formed by products of corresponding terms of an AP and a GP. So that means suppose we have an AP, that is arithmetic progression, given by A plus D, A plus 2D and so on. And we also have a geometric progression given by, say, the first term is 1 and the common ratio is R. So we have the different terms of the GP as 1, R, R square and so on. Now if you take the product of corresponding terms, so that means A into 1 gives us A. Alright. Similarly, the next term is R into A plus D, that gives us the second term and so on. So therefore whatever sequence we obtain, that is called as the arithmetico-geometric progression or AGP. Right. Now let us see the formula for sum of n terms of the AGP. Now here is the big formula for that. So it is A upon 1 minus R plus dr into 1 minus r raised to n minus 1 whole upon 1 minus r the whole square minus into bracket a plus n minus 1 times d whole into r raised to n upon 1 minus r. Now the procedure to obtain this formula is very much similar to the procedure which we use to obtain the sum of n terms of a geometric progression. So we first of all write the expression for that sum, then we multiply both the sides by common ratio r, and then subtract the one sum from the other sum, and then by rearranging we get finally this particular expression. Now if we have infinite AGP, that means if there are infinitely many terms in the AGP, and assuming that r is numerically less than 1, as we have seen in infinite GP, so in this case what happens is the term r raised to n minus 1 and r raised to n, both of these terms will tend to 0, simply because since r is less than 1, if we take any higher and higher power of r, it will eventually reduce and approach 0. So therefore since both of these terms are approaching 0, therefore the original formula for Sn of AGP will reduce to the formula as shown here, that is it will be a upon 1 minus r plus dr upon 1 minus r the whole square. Now let us solve one sum based on finding sum to infinity for this particular sequence. Now whenever we are given this type of sequence, first of all we have to make sure that we realize that it's an AGP. So let us separate out the two components, that is the AP component and the GP component. Now if we look at the numbers here, we can see that 1, 3, 5, 7 and so on, that means all odd numbers are appearing, which definitely form an arithmetic progression. So we have 1, 3, 5, 7 and so on. Now at this point let us remember that AP can never be an alternating sequence, in the sense that in an AP you can never have a positive term, then negative term, then once again positive and once again negative. It will be either an ascending or a descending sequence, or in critical case it will be all constant where the difference is 0, but otherwise it has to be in ascending or descending manner only. Now in GP the first term is 1, and we can see that the next term will be nothing but minus 1 by 2, so as to make the second term as minus 3 by 2. Then after that the next term would be 1 by 4, and after that the next is minus 1 by 8. So here it is clear that the common ratio r is nothing but minus 1 by 2, and we observe that it is less than 1, that is numerically less than 1, right? Then for AP we have the starting term as 1 and common difference d is equal to 2, That is because we have all the odd number terms present in the AP. Alright, so we have got A, D and R. So therefore let us write down the formula first for infinite terms of the AGP. Here it is given by A upon 1 minus R plus dr upon 1 minus R the whole square. So that turns out to be A is nothing but 1 upon 1 minus, now R is minus 1 upon 2. So it is minus 1 upon 2 plus D is 2 and R is minus 1 upon 2 whole divided by 1 minus 1 upon 2 the whole square. Right. So let us simplify that further. So here we get 1 upon 1 minus half is 1 plus half, that gives us 3 by 2 as a first term, and the second term 2 will get cancelled, so we have minus 1 upon, now in the denominator we have 1 minus half, that is 1 plus half, which is 3 by 2, and 3 by 2 the whole square is nothing but 9 by 4. So therefore which turns out to be 2 by 3 minus 4 by 9. So therefore on combining this we have LCM as 9. The first term will be 6 minus 4. So therefore that gives us final answer as 2 by 9. So that's the sum up to infinity of the given sequence.